everyone, welcome to the next session on Advanced MATLAB. In this session, we are going to discuss about the various algebraic equations and how do we find the solution for them using MATLAB software. We will start by solving basic algebraic equations in MATLAB. The solve function is used for solving algebraic equations. For example, let us solve for x in the equation x minus 5 is 0. For that, we are going to use this equation. You can also call the solve function as y is equal to solve x minus 5 is 0. You may not even include the right hand side of the equation for writing solve x minus 5. So these are the three ways in which you can solve an equation x minus 5 is 0. Just make a note of this operator. It is not a single equal to. It is a double equal to sign that is used. So we will take this to MATLAB now. I'll open new script, and the first thing that is to be written is to declare the variable. Here I have variable x, and then I will write the solve function solve x minus 5 is 0. Declaring this variable is very important, and I'll save this as say file A1. Next I'll run the file A1. You can see here the answer is 5. Now suppose if I write this as y is equal to solve x minus 5 is 0 and then I run A1 file again, you can now see y is equal to 5 is the solution. We have given a variable who will hold the value of this equation. And if I want to just solve x minus 5 and without equating it to 0, let's check if I get the answer for this. I'll just save the file and I'll run it again and again to see the result. So you can see here directly, answer is 5. So without writing equal to 0 also you can get the answer. If the equation involves multiple symbols, then MATLAB by default assumes that you are solving for x. However, the solve function has another form, solve equation comma variable, where you can also mention the variable over here. Say it is y, z, u, v, w, anything you can just mention here. For example, let us solve the equation v minus u minus 3t square is equal to 0. For v, we want to solve. In this case, we should write SYMS. This is the symbolic form for writing the variable. So there are three variables in this equation, v, u and t. Just add a space in between, no commas to be added. So here you are declaring u, v and t are the variables. S is equal to solve v minus u minus 3t square is equal to 0, and v is the one that we want to find. Display, the first root is display S. So this is how you are going to write. Let's take this code to MATLAB now. I'll save this as A2. So you can see once I run this file A2, I'll get S is equal to 3t square plus u. And if you also want to write the solution as the first root is in that form, you can display like this. Now, in either of the case, suppose if I don't want to see this line, I can just put a percentage sign and run it once again. I will only get S is equal to something. And suppose if I don't want to see this equation, S is equal to the answer, I'll remove this percentage sign and here I'll put a semicolon. Semicolon is used when you want to suppress the answer from being projected on the screen. So now you can see the first root is 3t squared plus u. So that's how you will get the answer for this. So once this is done, we will go to the next one. The solve function can also solve higher order equations. It is often used to solve quadratic equations. So now we are going to solve quadratic equations. The function returns the roots of the equation in an array form. The following example solves a quadratic equation x square minus 7x plus 12 is 0. Create a script and type the following code. So this is the code that we are going to write. Here we are writing equation is equal to EQ is a variable that we are using. X square minus 7x plus 12. When you have to write square, you use this symbol raised to, and between two numbers or between two variables or between a number and a variable, if you want to add a multiplication sign, this symbol has to be used, is equal to 0. S will solve and store this solution EQ. Since I have put in semicolon here, this solution will not be given directly. It will come in the form of display. The first root is, and it will give the answer of the first root, and display the second root is. So this will give you the second value. Now let's take this to MATLAB. I'll save this as file A3. If you want to clear the screen, use clear all. CLC will clear the screen and clear all will remove the values associated with the variable. So now I'll run the file A3. You can see here it doesn't give an answer. Now there is some error. We need to solve that. The error is we have not defined the variable x. So we need to write here syms x. I'll solve A3 once again. You'll get the first root is 3 and the second root is 4. So declaring your variable is very, very important. Let's see another example. The equation is ax square plus bx plus c is 0. So we will first start by declaring the variables in this equation. So syms, a, b, c and x. These are the various variables in this equation. Next I have typed the entire equation. Ax square plus bx plus c is 0. S is solving the equation and display the root in DSP1 and DSP2. So we will take this to MATLAB now. Now here when I am solving, I'll just put a semicolon such that the solution is not shown. I'll save this as A4. Now let's run A4. You can see here this equation. Since there is no semicolon here, it is again repeated. If I don't want to see, I'll put a semicolon here as well. The first root is minus b plus b square minus 4ac upon 2a, and this is square root. So this is root of value, and the second root is again root of minus b square minus 4ac upon 2a. We know this is the root of this equation, ax square plus bx plus c is 0. So suppose if I run once again by putting a semicolon at this spot, you will see that the equation is not repeated. This equation term is not there. Only the two roots have been displayed. If I want to clear the screen and the value of the variables, clear all, you can see the workspace has now become empty and CLC will clear this command window. So this is another way of solving a quadratic equation. Next we will see higher order equations in MATLAB. Suppose if you have a cubic equation, x minus 3 the whole square into x minus 7 is equal to 0. Suppose if I want to solve this, I'll write solve x minus 3 square into x minus 7 is equal to 0. Since it is cubic equation, there will be 3 roots to the equation. So I have written this display option thrice. So let's take this to MATLAB now. I'll save this as A5. This is still giving the error that x is not defined. So I'll define and I'll solve A5. The first root is 3, second root is 3, and the third root is 7 for this equation. Now let's take another equation. In case of higher order equations, roots are long, containing many terms. You can get the numerical value of such roots by converting them to double. The following example solves the fourth order equation x raised to 4 minus 10x square plus 9 is equal to 0. So we will write the script of this form. First we will declare the variable x, then we will write this equation, then we will write s is equal to solve equation, and finally we will display the 4 roots because the order is 4. So let's take this to MATLAB now. I'll save this as A6. So the 4 roots are minus 3, minus 1, 1 and 3. Now if you see here, double needed to be used to convert the roots to double type. So suppose if I have the same equation and I just add a word double here, we will see what kind of solution is obtained. So here I'll just write double. I'll open the bracket and again close the bracket. I'll save it once again. So let's run A6. You can see these are the roots obtained. Minus 3, minus 1, 1 and 3. Now let's solve another equation. X raised to 4 minus 7x cubed plus 3x square minus 5x plus 9 is 0. So we have done the same way of writing. Now here I am just going to add few more equations where I am going to add double. And here first we will see the displaying of the roots. So let's take this entire thing to MATLAB. I'll save this as A7. So there are various types of answers to be obtained. You can see here the roots at the bottom. These are going to be in the form of decimal and complex numbers. So this is the reason for writing double. When you get these kind of roots which are long in form, so that's how you obtain here. Now these 4 answers I have not got them. So what I'll do is I'll just go for. So this is what you obtain because it is in the form of complex conjugate. So you are not going to get the answer in this first way. You will get the answer by using the double function. Next we will solve system of equations in MATLAB. That is when we have more than one equation. So the solve function can still be used in this case. We'll create a script of the sort SYMS X and Y. S will solve these 2 equations. You can just separate the 2 equations with the use of a comma sign. At the end, we'll write s dot x and s dot y for displaying the solution. Let's save this as A8. So you can see here, these are the 2 answers, 22 by 19 and minus 5 by 57. That is what you obtain by solving these 2 equations. That is finding x and y. The value of x is 22 by 19 and y is minus 5 by 57. Now suppose if I want to find the decimal values of it, I am going to use the double command. So I will save this once again. A9. Let's run A9. You can see here the first root is 1.1579 and the second root is minus 0.0877. So that's when you want to get the decimal value and not the fraction one. Now next, if I want to solve 3 equations simultaneously, then in that case again the equation can be written in the same form. First you declare the 3 variables of the equation, and then S is solve and write the three equations and then display the roots. And see to it that you use double such that you are getting in decimals. So let's take this to MATLAB. I save this as A10. So the three roots are minus 15, 8 and 2. Now since there is no decimal value, hence it is just giving you the whole numbers. Now we will see how to expand and collect equations in MATLAB. The expand and the collect function expands and collects an equation respectively. The following example demonstrates the concept. When you work with many symbolic functions, you should declare that your variables are symbolic. So this is how you're going to write the script. You will declare the variables x and y that is occurring in these equations. So suppose if I want to expand this equation, that is I want to multiply x minus 5 into x plus 9. We know how to solve it. Mathematically it is x into x, it will give you x square. Minus 5 into 9 will be minus 45. And then minus 5 into x is minus 5x and 9 into x is 9x. So the answer when you solve will be x square plus 4x minus 45. Similarly, you can expand this equation. Also, you can expand sine 2x. You know the formula of sine 2x is 2 sine x cos x. Also, you know the formula of cos of x plus y, sine of x plus y. So they will give you the formulas of these equations. So that's how you use the command of expand. And when you use the collecting equations function is collect, that is x square into x minus 7. So when you solve, it will be x cube into x is x raised to 4 minus x cube into 7 is 7x cubed. So that's what the answer should be. So let's take this to MATLAB. So you can see the first one is x square plus 4x minus 45. The next one is having 4 terms. So the highest power will be x raised to 4, then x raised to 3, then x square and x, and then finally a constant value. The formula of sine 2x is 2 sine x cos x. Formula of cos of x plus y is cos x cos y minus sine x sine y. Formula of sine x plus y is cos x sine y plus cos y sine x. And when you are using the collect function, you can see here, this is x raised to 4 minus 7x cubed. And when you multiply this x raised to 4 into these three terms, x raised to 4 into x minus 3 into x minus 5, you get this answer. So that's how you use two more commands. One is expand and collect for expanding equations or writing formulas or using the collect option. Next is factorization and simplification of algebraic expressions. The factor function factorizes an expression and the simplify function simplifies an expression. The following example demonstrates the concept. So we will write a script SYMS x and y factor x cube minus y cube. So suppose if I want to factorize this formula, factorize and get the answer for this equation. Next is factorize x square minus y square into x cube plus y cube. And last is simplify x raised to 4 minus 16 upon x square minus 4. So suppose if you already calculate this manually, let's see if I get the same answer. I have saved this as A12. So you can see here, this is the first factorization of x cube minus y cube. The formula is x minus y, x square plus xy plus y square. These are the two factors. Next is the factors for these two multiplied together. So this is the answer. And last is simplify x raised to 4 minus 16 upon x square minus 4. The answer is x square plus 4. So with this I end the session. I hope you have understood the various ways of solving the algebraic equations in MATLAB. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.